The first gas law that we are going to investigate is that of Boyle's law. As we go through these four gas laws, know that we're going to be looking at the relationship between two of the four variables we talked about, and the other two variables remain constant. So Boyle's law deals with volume and pressure, the relationship between volume and pressure. You can see we have a couple of graphs over here, and it probably is not surprising that as you increase your pressure this way, that your volume is going to go down. That's probably to be expected. The gas law's formulas come from taking this data and looking at how we can get a straight line. So what they found when looking at a lot of data points is that if you took volume versus the inverse of the pressure, that you always got a straight line, which gives us this formula here, that volume equals K, which is the constant slope. The slope of the line is always constant, times 1 over P. And hopefully you can see that this is Y equals mx. And our y-intercept is 0 because if I have 0 volume, I would have 0 pressure. Now, if we look at two different points, P1V1 and P2V2, if I solve this formula for K, K is going to equal volume times pressure. So I would have P1V1 equal to K, and I would also have V2 P2 equal to K. Well, since they're equal to the same thing, we can set them equal to each other. So our formula for Boyle's law becomes V1 P1 equals V2 P2, where the 1 is we are looking at the initial conditions, and the 2 we're looking at the final conditions. And as you can see, I've got to keep these quantities equal to each other. So if I increase my volume, my pressure has to go down in order to keep these quantities equal to the other quantities. So this is an indirect relationship. As pressure increases, volume decreases, and as pressure decreases, volume increases. So we are going to see this Boyle's law in action. We're going to watch a YouTube video. This is a video of a flask that has some of those Easter peeps in them, and it's attached to a vacuum pump. So when the video starts, the air is going to be pumped out of the flask, lowering the pressure, and hopefully you'll see as you lower pressure what should happen to the peeps. So make a hypothesis, and here we go. All right, so we did see that as we decreased pressure, that the volume of those peeps increased. So there's Boyle's law in action. All right, the last thing we're going to talk about with Boyle's law is how we can work a word problem. We are going to use the guess process for showing work, which means you have to have all of this information shown in order to get full credit. So guess is an acronym. G stands for given, so you're going to list the variables with units that are given in the problem. U is the unknown, so you'll list the variable you are trying to calculate. E is the equation, so you'll list the equation you will use to solve the problem. S is substitute, so you'll plug in the givens and unknown into the equation, including units. And then finally, S is solve. You'll use algebra to solve for the unknown, calculating the answer for the unknown with the appropriate units. As you can see throughout this whole process, units are extremely important. So you're going to include units every time you are putting down a number. So here is our example. It's hard to begin inflating a balloon. A pressure of 800 kilopascals is required to initially inflate the balloon 225 milliliters. What is the final pressure when the balloon has reached its capacity of 1.2 liters? All right, so we'll give what is given. So I'm going to go ahead and circle, maybe. I'm going to go ahead and circle the variables. Let's go ahead and use black. All right, so we have 800 kilopascals, 225 milliliters, 1.2 milliliters, and we are looking for the final pressure. So I know that my unknown is P2 because that would be the final pressure. I'm given an initial pressure of 800 kilopascals, and I am given an initial volume of 225 milliliters and a final volume of 1.2 liters. Well, hopefully you can see that this causes problems because my units of my volume are not canceling. So I do need to convert one or the other. So I'm going to go ahead and change 1.2 liters to 1,200 milliliters. All right, so this is dealing with pressure and volume, so it is a Boyle's problem. So I'll write down my formula, P1V1 equals P2V2. I'll go ahead and plug in my units. So I have 800 kilopascals times 225 milliliters, and that's going to be equal to P2 times 1,200 milliliters. I'm going to use algebra to solve for P2. So I'm going to divide both sides by 1,200 milliliters. So hopefully you see that the 1,200 milliliters cancel. The milliliters here cancel. So I'm left with, when I calculate this, a final pressure of 150 kilopascals. All right, the last thing you should always ask yourself is this reasonable? So you have to ask yourself, what happened to our conditions? So we increased our volume, which according to Boyle's law should decrease our pressure, which is exactly what happened because we started at 800 kilopascals and ended at 150 pascals. So it is reasonable, but you should always take the time to ask yourself that question so that you can avoid silly mistakes.